so debugging closure sizes. Let's go share my terminal. All right. So we go into Nix packages, and well, let's try to find something that might be a little bit big. Let's do disallowed references. Okay, that's a good clue. So disallowed references, that's a way of saying to Nix that do not allow this package to end up in the result. Oh yeah, there was also a tool to make graphs. Yeah, I don't know how to run that. But so let's, for example, look at this one. So in this build OpenJDK, it says disallowed references OpenJDK 11. This means that if you build this package and this derivation ends up in the result that is being built, it's going to fail. This is a good way of ensuring that once you made a build work without that output, it's not going to be accidentally introduced afterwards. And we can try simulating this fairly easily here. Let's do post fix up. Let's say in our post fix up at the end, we accidentally do something like this, where we do make clear out something, and we do ln-s. We are going to link to OpenJDK 11. This might end up like this because of the build, the make file somehow propagating this. We're going to link this to OpenJDK. All right. And now we just need to figure out how to build this. Actually, I'm a bit surprised. This is OpenJDK 12. OpenJDK 11 is mentioned here. I guess 12 might be built with 11. Yeah. All right, so let's build OpenJDK 12. Next build OpenJDK. There is no 12. It might be the default. Is it? It is not. Well, then let me go to 11 instead. Let's copy this out. OpenJDK 11.nix. And we're just going to put it in here instead. Oh, down here. Oh, this uses Bootstrap. All right, now let's try building this. OpenJDK 11. I hope we didn't pick a too large build, actually. OpenJDK feels like it might be pretty big. We could actually, I feel like I want to share my entire screen, not just a single window, so I can switch to a browser window. Let me do that. All right, here. So we have the build running there in the background. I do want to check Hydra. So we go to hydra.nexus.org. Let's search, or let's go into the Nix packages job set. This is the main one, or there's both a NixOS one and a Nix packages one. Nix packages one is for mainly the Nix packages channels. They don't run the NixOS tests and so on. In here, there is at the very bottom, I believe, trunk that builds the master branch. The name is a bit of a legacy. I think it should be renamed if possible. But so in here, let's look at jobs. And let's search for OpenJDK. All right. Well, let's also search for, or let's go down here, yeah. So openjdk11.x6564 8664 Linux, that's the one I'm building right now. We can see that these are all the builds that have happened in the past, and they generally succeed. We can click on this to look at these builds more individually, or we can also click on an individual build. And now here we can see the duration of how long it took to build. And 6 minutes, yeah, it's still downloading things. So I feel like we should pick something else. But in here, I believe, is there? Oh yeah, here, history. So this is interesting. Hydra here provides a history of the output size of a build. I'm not entirely sure if this is the closure size or the output size of the package only. But we can see the evolution here over time. I think this is very interesting. Same for build time. We can see that it always took around 500 seconds. All right, so let's pick something else. Let's pick some edge package, git it maybe. Disallowed references. Well, let's check about git it, how long that takes to build. Git it, and let's scroll links. All right, click on the first build. 3 minutes. This is somehow all fairly long. I want like a super short build. Calibre. Nginx. No. Postgres, no. What about this? Exiv2. Exiv2. Okay, 2 minutes. I think we can do 2 minutes. So let's go in here. Let's go to disallowed references again. So it doesn't want the stdnfc compiler to end up in there. Let's do that. Let's mess around with that. Let's do this to out cc, sure. And let's try to link this.
Font bigger because it's very small.
Oh yeah.
Thank you.
Thanks. All right, so we're going to build this in the background. All right, so let's see. I hope this is documented somewhere. It's a good point. Where would it be documented? Nix, probably not here. Well, it should be in the Nix manual. Nix manual online. I'm going to search for disallowed references. This is the thing we currently are looking at. And find a search result. It's building in the background, so it's a bit slow. All right, so this is the option we just looked at. Yeah, you can also see it here described. A list of illegal references of the output of the builder. It forces that the output cannot have a direct runtime dependency on the derivation foo. And there's, I can see here, there's a bunch of other attributes like this. Allowed references specifies a list of legal references. Yeah, so disallowed references is like a blacklist of dependencies. Allowed references is like a whitelist of dependencies. Once you specify allowed references, I think you can only have the ones you list here. And we also have that, apparently I didn't know this, there's also one for requisites. So this is for the entire closure, not just direct dependencies. Similarly, disallowed references and disallowed requisites. Requisites is for the entire closure, and this is something else. Yeah. All right. And yeah, we can see the error here at last. So we built exif2 with cc in the output. Nix is complaining that we cannot refer to that store path. If we go back in here, disallowed references, if we were to remove this, so we don't disallow the C compiler to end up in the result. Try to build it. Going to take another 2 minutes. Meanwhile, let's search for allowed references as well. Oh, we mainly only have allowed references. Search for -w. All right, there's not a lot of them here. Linux. Yeah, but I guess this kind of shows the main use cases allowed references is used for, which seems to be limiting the dependencies to either nothing, so you have a result that doesn't depend on anything, or just out the output directly itself. We can set up an example like this. Let's do a nasty Nix packages import. Let's do a run command. Run command is a very simple builder to just run a command and have that be able to output to write to the result. So let's say we do just a echo test to out. All right. Let's build test.nix now. All right, that works. And if we look at the dependencies of this, so nix-store -q or -query, and then requisites, of the result, we can see that it actually outputs itself. That's a bit surprising to me. Requisites, and the other one is references. Okay, so yeah, references and requisites, again, we have references are the immediate dependencies, and requisites is the closure of the dependencies. Apparently, the closure also includes the package itself. Good to know, I guess. But we can see that direct dependencies does not include the output itself. But we can do that by just writing the out variable, which is the store path where the package is built, to the output itself. This makes it be a dependency on itself. If we build this, nix build test, then do a nix-store for the references, we can see that it's included in the direct dependencies as well. And requisites, again, that's also the one itself. But now if we were to do allowed allowed references to empty, we expect to get an error because we have out as a direct reference, as a direct dependency. So if we build this, yep, we get an error. It's not allowed to refer to this path. We can, again, allow this. This seems to be some special syntax, the out string here. I think generally you'd have to pass a nix-store path, but I guess this works. If we do this, it works again. We can also try allowed requisites. So this is the closure. If we don't allow anything in the closure, I'm now wondering if this Let's remove this. Let's just write test to out. So we don't have any direct dependency like this, but we've seen earlier that if we do a nix-store query requisites result, we get the result path itself too. So let's try this out. Does it work like this? That does actually work. Okay. I guess that's fair. Not allowing, or I guess you could always add the out here, but it feels a bit super unnecessary. Okay, so that's allowed requisites, allowed references, disallowed references, and disallowed requisites. If we go back to the EXIF example, here we did. So here we added CC to the output, which initially failed if we had this enabled. If we comment this out, it works, but we also end up with a CC dependency in the result. So let's just make sure we have it here. All right, and so if we try nix-store query here for sto requisites results, we can see in here we have GCC here, which is not good. And if we were to stash our changes, so we don't do anything like normal, like it's normally built, build EXIF, and then try nix-store query. Well, there is still GCC lib in here, but GCC itself is not here. Yeah.
Can I calculate the size of the closure?
Yeah. Good point. So I think that nowadays best way to calculate the size of closure is with path info. It's part of the new CLI, which is not stable yet, but I think this command hasn't changed in a while. So path info has help page. Let's look at the flags down here. We can use big S. Oh, here, closure size. Yeah, so this is the most interesting thing, I believe, here. And then we also have the -h flag for human output instead of bytes, which is much easier to read. So we can do path info -sh, or if we spell them out, closure size human readable of the result. And that doesn't work because we need to. It doesn't work on the result symlink. It needs to be the entire nix-store path. Here we can see this is the closure size of the original EXIF. Now if
Can you pass it /result?
Good point. That should maybe work. Yeah, that works. Awesome. So that's the original one. Let me redo our changes here. So EXIF2, we now echo the C compiler, and it should depend on the C compiler now. We can see this again. Oh, spill it. Let's query it. Depends on the C compiler, and the closure size is much larger. Previously, it was like about 50 megabytes. Now it's 250. So yeah, if you have something in the output and you don't want to end this up there, and you fix it once, you might want to use disallowed references to prevent this. But now, what if you really can't make that work? So then, well, you first got to try to make it work. Like, how do you figure out where a dependency comes from? And this is where the nix ydepends is a really nice tool. why depends essentially tells you why something depends on something else. So if you look at the help page here, we have two main arguments. We have a package and a dependency. These can be these flake references, but we can also pass it store paths directly. I tend to prefer store paths since it's not ambiguous what you refer to. So why depends? I hope we can pass /result here. Let's also look at the requisites. Let's copy this GCC path here. Let's do nix y depends /result and this GCC dependency. And we can see actually not that much. Just tells us that it does depend.
It directly depends on it, so that's why it shows it like.
Do we have?
It was supposed to tell what file causes the dependency.
Yeah, I also thought it should do that. Is that the precise? Oh, okay, that's the precise flag.
Okay.
So yeah, precise shows you exactly which file has the dependency. In this case, it's fairly direct since we have the CC file directly in there. We can also try it. So if you look at nix-store query --tree of the result, we can see the oh yeah, this is the entire tree. Fits perfectly on a page. Nice. So this is the tree of the runtime dependencies in the output. And say we want to figure out why we have the let's say this Linux headers dependency, or let's pick this lib unistring, which is deep down there somewhere. So let's do I copied the path. Let's do nix y depends. Let's also do precise /result and this path. And we can see here it goes all the way down. It recurses into all the derivations, shows us that in the exif2 derivation, we have the bin exif2 file, which contains this glibc string, which then contains a liblibc and so on until we get to the dependency we were asking for. There's also, so sometimes you have multiple, there's not just one of these dependencies, but multiple of them. So in this case, we have like, let's pick like glibc, very basic dependency. We can see it occurs here, it occurs here, here as well. So if we ask for this one, nix y depends, and glibc, we can only see one reference here. So if you want to get all of them, I think that's the all flag. And with this, we get a whole bunch more. So yeah, it would be really hard to get rid of this dependency because there's so many references to it. I think this is a good thing if you aren't sure whether a dependency is needed or not, to look at the y depends and see how many references there are. If there's too many, or you see that they are actually required in some way, then you might not be able to get rid of it that well. Okay.
By the way, I found it useful. Well, since I more work with flakes, I found it useful to also refer actually to flake references, because like then you can see like why exif2 dot hash exif2 depends on nix package hash GCC, for example, and it's more like it's easier to reason about this, I think.
Yeah, I don't have a lot of experience with using flake references like this. I feel like it might be a bit of a guessing as to to one store path. That's weird.
Does it have two outputs?
It's two outputs. Oh yeah, it has many outputs.
So dot out, I guess.
Oh, I see. Out, let's see. Oh, this one as well. Oh yeah, so apparently this doesn't work here.
But if you use .lib there, I think it will depend on GCC library, but not on the libc, I guess, not lib.
Let's see. Doesn't appear to.
Oh, wait,
yeah,
it says there's been.
Probably like this. No? Okay, I feel like we have to skip this for now.
Yeah.
But so something else that's interesting and kind of hacky and...
By the way,
yeah?
Can I have a related question?
Yeah, Alexander?
For the allowed requisites, is it just a good practice to always specify them then? I once tried to do that for stuff I was packaging, and I would say there was an ergonomic problem that you build something, you find a reference that you have missed, and now you have to rebuild it again, wasting some time, even though it hasn't changed a bit. But otherwise, what are other downsides of just always specifying them?
So you mean the disallow references and allowed references?
Allowed requisites will get ugly because it's transitive, and with real packages, it will be just tons of stuff. And you don't directly control it.
I think from what I'd say is that here. I feel like allowed requisites, so for allowed references, allowed requisites, because it's a whitelist and it disallows everything else, this is probably only useful if you have kind of edge packages. So packages that shouldn't contain anything really, and where it makes sense to specify like an empty list, or I only depend on this one dependency. I don't use it there. We can also see, we could see in Nix packages, there's barely any uses of allowed requisites. And yeah, it does cause a rebuild, but you only have to add this once, and then you get essentially the benefit forever. So I think that's a fair trade-off. The disallowed.
Allow me to rephrase. If you're a maintainer of some, I don't know, libidn, and you know that you have just, I don't know, 7 references, would it be a good packaging practice to just spell out all 7 of them in this attribute and be safe about this list growing?
No, I wouldn't do that. I think it should only be used when you actually have something that seems to persist as a problem where people accidentally introduce some reference in the output. And in the past, that has happened. And I know you might have fixed that twice already, and you want to prevent people from doing that accidentally again, especially with like compiler outputs that might end up in there accidentally. There are some builders in Nix packages which might which handle compilers and so on, and sometimes there it's a bit tricky to make it work without compilers ending up in the result. And so once someone went through the trouble of fixing this, they can make sure that people don't break it accidentally again in the future. So
especially for I don't process where you actually have to have a package that doesn't depend on anything to bootstrap from, then it would be, I think, useful to have no allowed requisites or something like that, or just a very limited amount of allowed requisites. But outside of that,
Yeah.
I think
Yeah,
the
so
main-
only
I think the main point here is that with allowed requisites, you sort of take responsibility for the entire closure that you're producing. And you're saying that no matter how I build this, I want it to only depend on these things. But that is a huge responsibility in case you have any complicated dependencies, because if you say depend on some other library, you're now basically saying that I do not allow this other library to acquire more dependencies in the future, because I have said that this library and all my other requisites are the only set I will support. So for a generic package, I would never really use allowed requisites, because you basically, your package will break as soon as one of your dependencies acquire another dependency.
Yeah, I'm not arguing with that, and I only used it when I had control over all the closure.
Yeah.
But my question was about allowed references, which is a milder thing. As a maintainer of the package, you should be like, you should know the whole list of your direct dependencies, and I don't really see the downsides of just freezing it for every package in Nix packages, basically.
Yeah,
Why would
I
that
would
be
agree.
a bad idea?
you might not have, like, for example, if you use a compiler or some tool that generates files for you, which compiler is such tool, it might leave additional references to additional libraries or something in your package, and then you will have to add it to your allowed references as well. But if someone would want to build your package with different compiler, they might want to use their own compiler and pass it to your package, and then the build will break because it has more references. Like, for example, compilers always leave references to dynamic loader from glibc, right? But if I want to build for muzzle, for example, then I will have to, like, change it. Or if I want to build for some esoteric system where we don't have dynamic loading, then you'll have to change the list of allowed references.
That's an excellent point. Basically, every tool chain will have to maintain and like, export a list of what's injecting. Yeah, okay, got it. Thanks.
all right, nice. Thanks for answering that.
I also have a question in chat from Noon.
Oh yeah. Okay, that if we have time towards the end, we can maybe take a look at that real quick. For now, I want to show a bit more clever stuff. And Noon, we have I am intending to open maybe a GitHub issue board where people can add their questions, and so we can go over them a bit more structured and link to the videos where these questions have been discussed. I feel like this would be a good idea for the future, especially as more people have questions. Also gives the people a way to know what is being discussed in the next hours. Something I do want to show off here is, so once you do have a dependency on something and you don't really know how to get rid of it, because to get rid of it, you need to edit a lot of files and you need to recurse into whatever. There is a kind of hacky way to still get rid of references, and that is the removeReferencesTo function. We can maybe take a look at it here. So the removeReferencesTo replaces all references to a given nix-store path with just a bogus store path. And this is only useful for getting rid of dependencies that you know are not actually needed at runtime. So kind of dangerous, somewhat unsafe, because you end up with essentially references to files that are broken in the result. But if you really need it, this can be done. Remove references to, let's see, do we have any good uses in here?
I actually used it once. Like, I haven't used it, but I tried to invent it. This is when I used a TCC compiler, which I knew was standalone and none of the references mattered. But if I took it from Nix packages, it had some reference, which I had to just strip with replace. And
Yeah, it's really sometimes useful. And here, just as an example, we can see a Go package, which apparently doesn't want the Go compiler to end up in all the binaries. I think Go might do that by default. So here they went to the extra mile of explicitly removing these references. If we, well, what is this? Quorum. Quorum, if we build this, we can see it actually doesn't download any Go compiler. Let's see if we look at the requisites of this. Yeah, it doesn't depend on Go. And if we don't do this, Nix build. It's going to rebuild it. Well, something else I want to do. If we build, just want to add it back for a second. Build it again. If we look at the result here, let's do like result in this maybe. Search for E. Here we have an example. So in here, this is the binary, and it depends on this E path, which is obviously bogus, but this is what the removeReferencesTo does. Okay, this is gonna build for a second. Yeah.
While it's building, when you get the size to a package, you're focusing on package. But if it's like you're rebuilding the whole Nix, for example, Nix OS, right? Like where you get more of like bigger chunks and everything, would the debugging would be done in a similar way?
Yeah, so I think debugging is mainly nix-store, so nix-store query, and then requisites or references. Requisites for closure, references for direct dependencies, and nix y depends. And so nix y depends. Over here we could see Go was added again if we don't have the removeReferencesTo. Well, I guess the last step is you can nix-store and nix-y depends, but then once you do know the dependency, you need to somehow figure out how to remove that dependency. If we look at, yeah, we can use this as an example. So we have that the quorum package depends on Go here. If we look at y depends result Go, well, then it's this size. And let's use full. We can see all the references. Well, I guess it's a bit hard in general, I'd say. In this case, it's somewhere in the binary. Generally, this indicates that the compiler produces it like this. Something kind of more common is that, let's say we have a test package, and let's remove these for now. Let's say we produce a binary. So let's actually write shell script bin. Let's test, and in here we write like. Actually, no, this isn't the right example. I think stdinf.make derivation does it better. Let's give it name foo. Let's give it some build phase. And then here, let's let's write a script. I'm going to write here a script, which is going to be something like, so this could be anywhere. For now, we're going to do user bin env, and then let's use Perl. Actually, no, I don't want to write Perl. Let's do bash Python. Sure. Let's do like a print hello in here. And then let's do pass as file. Pass as file allows you to pass a variable that you pass to the builder as a file. So it serializes this to a file and then allows you access in here. So here we're going to copy the script path. So the file ends up under the script path variable. We're going to copy this to out bin script. Let's do make dir p out bin. And we need to make it executable. Script. I'm a bit loose with quoting here. But so there is the, I think it's the fix up phase. Patches shebangs in scripts, in executable scripts. I believe it only does that, though, if you have the relevant package in your path. So if we try this.
You have to change the closing bracket there.
Oh. Oh, yeah, thanks. If we build this, oh, we don't have a source. Fair enough. Unpack phase equals. Just do this. Oh. What phase is this? Building this. We don't have an install phase. All right. Install phase equals. Let's also just do nothing. We install it in the build phase for now. And this works. Now let's see what the result is. So the script, currently it doesn't get substituted. I believe now, I hope this works. If we add a, let's do native build input, I guess. Or build input would actually be better. We do Python 3. Now build the result. And, oh yeah, we can actually see it here. Nix-store script interpreter directive changed from Python to the Python interpreter directly. So now if you look at it, in the result, we can see the default store path in here. And so this is a kind of more common way to end up with a runtime dependency. So now if we do the Nix y depends result on Python, this path here, and let's do precise. We can see it here. The shebang has been changed. Yeah, and then I mean the resolution here is kind of, I guess, figuring out whether this binary is really needed. If you can remove the binary. You can also prevent it from being patched. I'm not entirely sure. Don't fix up, maybe. I guess don't fix up could be used, yeah. Though it's a bit of a hammer. But if we use don't fix up equals true, so you might use Python at build time, which, well, in this case you would use native build inputs, but you might use it at build time, but you don't want it to be used at runtime. You don't care about the scripts the Python installer might create. We could say, well, don't fix up. I not generally recommend it. Recommended. A bit of a hammer. I do believe there's also more gradual ways to prevent this from happening. But yeah, if we do this, next build test.next, nothing is done here. We can see the output hasn't changed. And so here we end up with the same line as we had originally. And in this case, I guess the script still is there, but it's going to use the Python from the environment, from the runtime environment that you use in the end. Alexander points out there's don't patch shebangs. Thanks. I guess that's just a Boolean flag. That's nicer than don't fix up. So this test on Nix. Oh yeah, the fix up phase does some stripping of binaries, which is by default stripping of binaries. I think patching up shebangs might do other things. But yeah, this also works. We don't have Python in here now. Yeah, and maybe quick explanation of how Nix even gets runtime dependencies to packages. So it essentially just does a grep over the result. I think we talked about this in past videos as well. It basically does a grep, but notably it only does a grep on the build inputs or on the derivation inputs. So the test example here, if we look at the derivation itself, because we can also do instantiate test on Nix like this. We can see the input derivations are these. So Python is an input. Because of that, it searches for this in the output to make it a runtime dependency. If we don't depend on Python, it's not going to do that. So let's simulate something that's a bit weird here, just to demonstrate this. So let's copy this file path. Well, actually, this is the input file path. We need the output. Let's quickly do this. Oh, I don't want the debug output. Let's do Python 3, like this. So this, let's just copy this store path. Don't do this, but we're going to try it here. And let's copy it in here directly, like this. Oh, where did it go? Copy and copy it in here. All right, and then bin Python 3, sure, which is Python. And we're not going to add Python as a build time dependency or as a runtime as a dependency here. And now, if we build this, build test.nix, and then look at the requirements of this path, query requisites, or all the requisites, we can see it doesn't depend on Python. So while in the result, we do have this Python path, and this Python path might exist. It might also not exist. So I could go in here, take this path. I could say nix-store delete this path. Oh, not everything. Where is it? Nix-store delete. Oh, it's still alive. Actually, this. Oh, I guess other things might depend on this Python path. Well, I guess we can figure out why it's still alive. Oh, my entire system depends on it, apparently. Yeah, that's not a great example. Let's use...
You could use Python 2. Hopefully less stuff depends on Python 2.
Yeah. Or actually, let's use like something I don't even use, like Quorum, which doesn't provide a Python interpreter, but we can try it. So let's just assume this is Python. We're going to build the test package here. It still doesn't depend requisites result. It doesn't depend on the derivation there. And now we can delete this. As I said, we can delete this. Nix-store delete this path. Oh, it's still alive. Why is it still alive? Definitely am not depending on this.
Why isn't it showing up in requisites?
So it's not showing up in requisites because it's not a derivation input. If we look at the derivation, we can see that the store path of the quorum package is not in the inputs. And Nix
but it
only
was
grabs for
grabs for
Nix only grabs for the inputs of the derivation in the output. If it doesn't occur in the inputs, it doesn't grab for it in the output. And so while we have this path here ending up in the output, there's nothing telling Nix that this could be an output. Like there's nothing telling Nix that this was an input originally. And so it doesn't grab for it, and it doesn't become a dependency. This is why theoretically, we should be able to delete it here. It's a bit weird that we can't delete it. Is it sudo nix-store delete, maybe? Nope. Do I have it in my local directory here? Maybe result symlink? Nope. Well, not sure about this, but we are about out of time. But yeah, so this doesn't register the derivation as a dependency, so you can't rely on it existing. Yeah, so I mean this just kind of shows don't copy nix-store paths into like anywhere. Have Nix handle
Unless you
these
really
store
know what
paths.
you're doing.
I'd say it's very rare that this is a good idea.
I saw one place where it was used in Nix and for really early bootstrapping.
Oh yeah, the bootstrapping. Yeah, that's an example. But yeah, generally let Nix handle these paths. Use the interpolation here. So let's use Python 3. Like if you have the script right in here, you can just do this. Or even better, you could use a writer, a Nix package writers that write Python or something like this, which does this for you and also handles dependencies and so on. All right, but yeah, we're out of time. I'm gonna try to make a GitHub issue board for next time so everybody can add questions there. And yeah, Noon, thanks for your question anyways. We might get to it next time. Yeah, thanks everybody.